break down every major branch of mathematics in the simplest way possible. These branches are divided into three main categories, namely pure mathematics, or theoretical maths, then applied mathematics, or the math in real-world applications, and the third one is, this category doesn't have a name, so we will call it other maths. Let's begin with pure mathematics. Arithmetic. Arithmetic is the simplest and oldest part of math. It's all about numbers and basic operations: addition, subtraction, multiplication, and division. It's the math you use every day when counting money, measuring ingredients, or splitting a bill with friends. Algebra. Instead of using only numbers, algebra uses symbols like x and y to represent unknown values. It helps us create equations to solve for missing information, like solving a quadratic equation to find the unknown variable x. Geometry. Look around you. Buildings, roads, and even nature follow geometric patterns. Geometry is a branch of mathematics that deals with the study of shapes, sizes, positions, and properties of objects in space. It explores concepts like points, lines, angles, surfaces, and solids, and how they relate to each other. The word geometry comes from the Greek words geo, which means earth, and metron, which means measurement, originally tied to measuring land and understanding the physical world. Trigonometry. Trigonometry sounds complicated, but it's really about studying triangles and their angles. Its name comes from the Greek words trigonon, which means triangle, and metron, which means measurement. So it's literally about measuring triangles. At its core, trigonometry deals with these 6 key functions, which let you calculate unknown sides or angles if you know some of the others. If you've ever used a map or a compass, you've already used basic trigonometry without realizing it. Next up, we have calculus. Ever wondered how we predict the movement of planets, the speed of a falling object, or even how fast a disease spreads? That's calculus. Without calculus, we wouldn't have physics, engineering, or even computer graphics for video games. Calculus splits into 2 big ideas: derivatives and integral. Derivative, which measures slopes of curves, tells us the rate of change of one quantity with respect to another. If you are driving and your distance traveled is given by s of t, where t is time, then the derivative of distance with respect to time gives us speed. Integration is the reverse process of differentiation. If a car's speed is given by v of t, and we want to find the total distance traveled by the car, we integrate it like this. Next up, we have topology. Imagine you have a rubber band and stretch it into different shapes without cutting it. It's still the same loop, right? While geometry cares about exact shapes, sizes, and measurements, think about rulers and protractors, topology focuses on properties that stay the same, even when you bend, twist, or stretch something, as long as you don't tear it or glue new parts together. Key ideas in topology include connectedness, like a circle is connected. 2 separate dots aren't. Then holes, like a sphere that has no holes. A donut, also called a torus, has 1 hole, and a pretzel has more holes. And then homeomorphism. If one shape can morph into another without cutting or gluing, like a square into a circle, they're topologically the same. It's used in advanced physics and even explains how your brain forms connections. Then we have number theory. Number theory is a branch of mathematics all about the properties and relationships of numbers, especially integers, and more specifically, prime numbers, which are the numbers that are greater than 1 and have exactly 2 factors, 1 and the number itself. It's one of the oldest areas of math, dating back to ancient civilizations like the Babylonians and Greeks, yet it's still alive with many unsolved puzzles today, like this one called Fermat's last theorem. which was proved in 1994 after 350 plus years. Or this one, which is the Goldbach conjecture, which is still unproven, or this one, which is twin prime conjecture. Nobody has proved this yet. If you do, you'll become famous in math history. Number theory explores patterns in numbers and is the foundation of cryptography, the technology that keeps your online passwords safe. Without it, online banking and digital security wouldn't exist. Next up, we have combinatorics. Combinatorics is highly focused on counting, arranging, and combining things like how many different ways can you arrange 4 books on a shelf? How many different meal combinations can you create from a menu? Combinatorics helps us count possibilities efficiently, and it's heavily used in computer science, chemistry, game design like Sudoku, or Rubik's Cube solutions, and probability. Then we have mathematical logic. Mathematical logic is the branch of mathematics that studies the foundations of reasoning.
झंझनाहट से जल्द आराम पाएं सेंसोडाइन रैपिड रिलीफ के साथ।
Logic. Mathematical logic is the branch of mathematics that studies the foundations of reasoning, proof, and truth using formal systems. It's like the rule book for how math works, writing arguments down to symbols and structures to make them airtight. Consider a statement. If it rains, then the ground will be wet. If P represents it rains and Q represents the ground is wet, then the statement can be written as P implies Q. This means that if P is true, then Q must also be true. However, if P is false, the truth of Q does not affect the implication. To understand this better, consider the truth values. If it rains and the ground is wet, then P implies Q is true. If it rains but the ground is not wet, then P implies Q is false. If it does not rain but the ground is still wet for some other reason, then P implies Q is still true. Finally, if it does not rain and the ground is not wet, then P implies Q remains true. This follows the standard rule of implication in mathematical logic, where the only false case is when P is true and Q is false. Mathematical logic shows up in algorithms, programming languages, debates about knowledge and existence, and also in the reasoning of AI, like ChatGPT. Now we will jump to our next category, which is applied mathematics, or the math in real-world applications. First up, we have statistics. Every time you hear a percentage on the news, like election polls or sports stats, that's statistics in action. Statistics splits into 2 main flavors: descriptive statistics like mean, median, mode, standard deviation, and inferential statistics like hypothesis testing, confidence intervals, and regressions. Then we have probability. Probability is the measure of how likely an event is to happen. It tells us how uncertain or certain something is using a scale from 0 to 1, where 0 means impossible and 1 means 100% certain. If you flip a fair coin, there's an equal chance of getting heads or tails. Each has a probability of half. If you roll a fair dice, the chance of landing on any number 1 to 6 is 1 out of 6. It's used in gambling, weather forecasting, quantum mechanics, AI, or machine learning to be specific, in order to predict outcomes from data, and even in insurance calculations. Every time you take a risk, probability is at play. Then we have game theory. Game theory isn't just about playing games, it's about making smart decisions in competitive situations. Each player has choices or strategies. The outcome depends on everyone's decisions, not just one person's. And the goal is often to maximize rewards or minimize losses. Businesses, governments, and even nature use game theory to predict behavior and find the best strategies. It's how companies set prices, how animals compete for food, and even how negotiations work. A famous example of game theory is the prisoner's dilemma, where two criminals are arrested and interrogated separately. Each must choose whether to betray the other by confessing or stay silent, which means to cooperate. If both stay silent, they get a light sentence. If one betrays while the other stays silent, the betrayer goes free while the other gets a harsh punishment. If both betray, they both receive a moderate sentence. This dilemma highlights the tension between trust and self-interest, showing that rational individuals may act against collective benefit when they cannot communicate or trust each other. Then we have numerical analysis. It deals with approximating solutions for equations that may be too complex to solve exactly, ensuring accuracy while managing computational errors. One example is solving the equation x equals cosine of x, which cannot be solved algebraically. Using the Newton-Raphson method, this iterative process refines the solution, demonstrating how numerical analysis provides approximate solutions for unsolvable equations. In engineering, it is used to simulate how bridges withstand stress, or how fluids move through pipelines. In physics, it helps solve differential equations that predict planetary motion, or model weather patterns.
ज्यादातर आम बीमारियां हाथों से ही फैलती हैं, इसीलिए चाहिए डेटॉल का बेहतरीन जर्म प्रोटेक्शन।
12 घंटे प्रोटेक्टिव शील्ड डेटॉल।
मेरे पास एक इम्पोर्टेंट स्टोरी, ध्यान से सुनना, बहुत ही जरूरी।
अरे थारे से पीसो कैसे निकालना है, मैं अच्छी तरह
Predict planetary motion, or model weather patterns. The finance industry relies on numerical methods to estimate stock prices and assess risks through predictive models. Then we have control theory. Control theory focuses on regulating systems to achieve desired outcomes by automatically adjusting inputs based on feedback. It ensures stability, efficiency, and precision in dynamic systems. In engineering, it is used in cruise control to maintain a car's speed and in drones to stabilize flight. Robotics relies on it for precise movement adjustments using sensor feedback, ensuring balance and accuracy. In aerospace, control systems guide spacecraft trajectories and manage autopilot functions in airplanes. In biology and medicine, it helps manage glucose levels in diabetic patients through insulin pumps. Graph theory is a branch of mathematics that studies structures made of vertices, points, or nodes connected by edges, lines, or links. Social media, Google Maps, and even your brain's neural connections all rely on graph theory. It helps us understand traffic flow and even friendships on social media. Now we will move to our last category, other maths. First up, we have set theory. Set theory deals with collections of objects called sets and the rules governing them. At its core, a set is just a group of things such as numbers, letters, people, which are defined clearly like this. Then elements, which are the things inside the set. Also, these are the key operations we do on sets. Then we have chaos theory. It is the study of complex systems that appear random but follow underlying patterns and are highly sensitive to initial conditions, often called the butterfly effect, where a small change can lead to massive consequences. Weather is a classic chaotic system where a tiny shift, like a gust of wind, can snowball into storms or sunshine elsewhere. The human heart doesn't beat with perfect regularity. Slight variations in rhythm are natural and even healthy. However, Excessive order or rigidity in heartbeats can indicate potential cardiac issues. Chaos theory helps analyze electrocardiograms, ECG, to detect irregular patterns, such as arrhythmias. Engineers and physicists apply chaos theory to improve aircraft design and understand ocean currents, such as the complex eddies in the Gulf Stream. Then we have fractal geometry. It is the study of self-replicating, infinitely complex patterns found in nature and mathematics. Fractals exhibit self-similarity, meaning their structure looks similar at different scales, no matter how much you zoom in. These structures are found throughout nature, from the branching of trees and blood vessels to the intricate patterns of coastlines, clouds, and snowflakes. In computer graphics, fractals are used to generate realistic landscapes, textures, and visual effects in movies and video games. They also play a role in signal processing, where fractal-based algorithms help compress images and audio. Then we have information theory, which is the mathematical study of data compression, transmission, and processing, focusing on how information is measured, stored, and communicated efficiently. Lastly, we have tensor calculus, is a mathematical framework used to describe relationships between multidimensional quantities, making it essential in relativity, machine learning, and physics. In Einstein's theory of relativity, tensors help model how space and time warp due to gravity. In machine learning, tensor operations power deep learning frameworks like TensorFlow, enabling neural networks to process vast amounts of data efficiently. In physics, tensors describe stress, strain, and electromagnetic fields, providing a unified way to analyze complex systems. If you enjoy my videos and want to support